Yo, 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 this is Mr. O. And today we're going to learn about exponential function and their graph. Okay. And exponential function is in the form of f of x equal to a to the x, wherein a is your base. And obviously, x represents your exponent. Okay. And today we're going to graph it. So a here has to be positive or greater than 0. It cannot be equal to 1 because if it's 1 to the second power, 1 to the third, the answer will always be 1. Okay. And let's try to evaluate it. Okay. So let's say we have here f of x equals to 5 to the x. We're going to plug in the negative 2.2 right there. We're going to plug in the negative zero point 0.5 to the x here with a 1 half and with a 3. And I need you to get your graphing calculator and plug in. This will help you to familiarize yourself solving for exponential expression or equation. Okay, so let's go ahead now. 5 to the negative 2.2, and that will give me 0.0289. Okay, 2 raised to the negative negative zero point 0.5 close 1.4014 and zero point 0.6 to the 1 half, that will give us 0.774, and 1.05 raised to the 2 times 3, we'll choose 6, so that will give me 1.34. Okay, there you go. Now let's try to graph of exponential function. Okay, we know that b here is the base. Graph of exponential function. So we're given here f of x equal to 2 to the x. B is the base here. We know that b is the base. Okay, b is the base in graphing. Okay, so there's a pattern to make it this simpler. Okay, and I like you guys to do the table. I need you to write the table here. Um, there's a pattern. This is the x and that's the y. Okay. If you have negative 101, the pattern here is 1 over b, 1 and the b. Why is that the pattern? What is the meaning of that one? If you have 2 to the 1, if the value of x is 1, the answer is just 2. So whatever the base is going to be the same. 2 to the 0 is always equal to 1. But if you have 2 to the negative 1, let's say 2 to the negative 1, you're not allowed to have negative exponent there. So it has to go down. It becomes 1 half. So the b goes down. Okay, that's the reason for having this chart here. Okay, so I need you to get familiar with that one. So here, since the value of my b here is equal to 2, this will be now 1 half. This will be now remain 1, and this will be 2. So plotting the points here, I have negative 1, 1 half right here, 0, 1 right here, 1 up to there. And if you get bigger value of x, it goes higher there. It's exponentially growing. In the same time, if you pick a negative 2, it's going to go lower and lower there. So what do we notice about our graph? First, this one here keeps going higher, right? And this one keeps getting lower and closer to our asymptote. Okay. So to answer the characteristic here, what is our domain? The domain here is that goes further to the left and to the right. It goes from negative infinity to positive infinity. The range here is it doesn't touch the asymptote of 0, so that means from y greater than or 0, or we can say parenthesis 0 infinity in interval notation. It will not cross 0 because our horizontal asymptote is y is equal to 0. And intercept, it crossed the y-axis there, which is 0, 1. And yes, it's continuous. It continues as the it is continuous because it keeps going. You know, you don't have to raise your pen up to trace the entire graph. Yes, it's continuous there. Okay, we're good with that one. So what if we change a little bit here? What if we make it negative x. Okay, how will this impact our graph? If that's negative x there, it just changed the problem. Basically, that's 2 to the negative 1x there. But if you have 2 to the negative 1, we know that it's also 1 half of the x. And the base here becomes smaller than 1. So it becomes from 0 to 1. If you have 0 to 1, this is exponential decay. If it's decay, it's going down. Unlike the other one, the base here was bigger than 1. So this one is exponential growth. So if it's exponential decay is going down here and applying the table here, so if you have, what's the pattern again? Negative 1, 0, 1. This will be 1 over b. This will be a 1, and that's the b. But since now we know the b here, the b that I'm going to use here will be the 1 half, not the 2 here. Because remember, this is in the form of 2 to the negative x. I'm going to use the 1 half. So 1 divided by 1 half. If you have a dollar, you split it to 50 cents. That makes it 2. A 0 will still be a 1, and a 1 will still be a half there. So graphing this will give us negative 1 up to here, 0 to 1, and this portion here will be 1 and 1 half right there. And you connect this going that side, and this will go going further down here, and it's kind of reflecting compared to the exponential growth. And the domain here will be the same from negative infinity to infinity, the range here from 0 to infinity. The intercept still the same, which is 0 1. Horizontal asymptote is y equals 0, and yes, it's still continuous. Okay, all right, so skip that one. Remember that 2 to the negative 1 is 1 half. 3 to the negative 2 is 1 3 squared, or just be 1 9. If you have a negative exponent, that whole thing should go down like this one here. And if you have a negative x there, you can flip it like what we did in the previous example. We have 1 half to the x. Okay. So let's graph this function here. Okay. F of x goes to 3 to the x. Um, so we'll do x and y here. And we know if the x is negative 1, 0, 1, it will give us 1 over b, 1 and b. But on this case here, for f of x, the b here is equal to 3. So this will be 1/3, 1, and what is this? 3 here. Okay. I should have used red here to make it even. Okay. All right, so I'm going to use red because the f of x is red. So I'm going to go to the negative 1, 1/3, 0, 1, and then 1 and 1/3 right there. So my graph will be something like this for the f of x. Well, for the yellow one here, or the orange one here, so x, y, here's what you need to do here. The base here is same thing as 3, like the red one, but there's a minus 3 here. There's a pattern here, guys. Okay, the pattern here is that b x minus h plus k. The h here is still horizontal movement, and the k is a vertical movement. Means say if that's x minus 3, the graph will move horizontally. On this case here is negative 3, you go to the right 3. That means you're going to add 3 to the x value. So following the pattern here on the red table here, I'm going to add 3 to all the x value here. I'm going to add 3 there. If I'm going to add 3 there to the x value because it shifts to the right, so the x is the only thing moves, 3 plus negative 1 is going to be 2, 3 plus 0 is going to be 3, 1 plus 3 is 4, and the y value did not change because I don't have a k. At this point, my k is 0, so it's still going to be 1/3, 1, and 3 here. So if I graph the orange one here now, it will be 2 and 1/3, 2 and 1/3, right somewhere here, 3, 1, and 4, 3. You will see if you compare the orange and the red graph shifted to the right 3 units and becomes the g of x. Make sense? Good. Let's do another one here. What about here if I have the h of x here? This time is plus 2. It's not minus 3. So therefore, I'm going to move the parent function, the 3 of x, to the left by 2. So this time, instead of adding 3 like the previous example, I'm not going to add 3 there, but I will move to the left. So I will subtract 2 here. So therefore, my table now here will be minus 2 here will be negative 3. 0 minus negative 2 is negative 2. 1 minus 2 is negative 1. And this will still be remain 1/3, 1, and 3 here. So if I graph it, I'm going to go to negative 3, 1/3, negative 2, 1, and negative 1, 3 here. If you notice, compare the red and the black graph, the red graph shifted to the left 2 units. Okay? That's very doable, right? It's like you just have to know if it's left or right. If it's minus, you go to the right. If it's adding, you go to the left. Okay. What if we put a k, a vertical transformation there? Okay. So again, the pattern is x and y. We know that this is negative 1, 0, 1, and this will become 1/3. This is going to be 1, and that's 3 there, right? Since this one is minus 3 here, we will subtract 3. This is for the k now. The negative is the k. So it's a vertical. Anything vertical, up or down, it impacts our y value. Nothing is fixing on the x. No horizontal shifting. It's just only vertical. So you're going to go down by 3. So we're going to subtract 3 to the y value. So we're going to subtract 3 right here. If we subtract 3 there, we're gonna use green one here. So it's the x value will remain negative 1, 0, 1. 1/3 minus 3 is going to be negative what? 2 and 2/3. 1 minus 3 is negative 2. 3 minus 3 is 0. So if we graph this will be negative 1 down negative 2/3, around like this much here. 0, negative 2, 0, negative 2, and 1, 0. Okay. If you notice here, the graph has went down 3 units. And also, watch here. The red, the black, and the orange graph, the first three functions, their asymptote was this y equals 0 there, right? That's the asymptote because the value of k there is 0. Look at the green one. The vertical shifting is 3. The vertical or the horizontal asymptote changed now to y equals negative 3. So the green graph gets closer to the horizontal asymptote there. Okay. So the last number, the k, represent also your horizontal asymptote. Okay. And for the last one here, let's do this. This time it's a combination of horizontal and vertical. So please pay attention here. So we know now that there's a minus 4. So that means we're going to go right 4. So we're going to add 4 to the x value. So we're going to add 4 here. 4 minus 1 will give us 3, 4, and 5. And the one here, which is our k, we're going to add 1 to our y value. 1 plus 1/3 is 1.3, or y or 1/3. 1 plus 1 is 2, 3 plus 1 is 4. So now we can graph our asymptote. Let's erase everything here to have enough space. So we will go to 3 and 1 and 1/3. 3, 1 and 1/3. 4, 2, and 5, 4. And we know that the value of your k is 1. So the asymptote is this, y equals 1. So therefore, the graph goes something like this. Okay. There you go. Okay. Very doable. Okay. All right. That's all for me today. We'll continue in the next video. As always, kaboom.